All right, everybody, so this is a demonstration that I just don't have time to show everybody in class because of materials and the like. But what I've got here, this is just the metal coffee cup. But I have one thermometer, which is thermometer 1 on the outside of the container, and I have another thermometer touching the inside metal part of the container. I'm going to pour the hot water in here, and what I'm going to do is I'm not going to pour it obviously up to the inside of the container's thermometer because I'll wreck the thermometer, but here goes in the water right now. So that water now is sitting about halfway up the coffee container. The inside thermometer is about 3/4 of the way up the coffee container, and you can see on that we got just a temperature spike right there on the inside. So the inside temperature on the cup is massively different than the outside temperature transfer. We can see on the outside, it's really not hardly changing at all, maybe a little bit, just like we saw when we had the 3 materials. But boy, the one on the inside of it just seems to be spiking up. So now we have a real conundrum where the inside metal seems to be able to make hot move from hot to cold really easily, and the outside of the container seems to have a really hard problem making hot easily move from hot to cold. So it's really odd. We have, again, a conundrum here of one part of the metal seems to move the heat really well, and the other part of the metal seems to not move it at all. So what could possibly be accounting for these differences in the lines that are being made? And we'll just continue to watch this for another couple minutes. You can see the temperature's kind of waving around, but certainly the inside is getting a lot of temperature to it. And again, the inside thermometer is not touching the hot water. It's just touching the inside of the metal container above where the hot water is located.